Oh, hey guys. How's it going? Yeah. You look great. See you later.
My name is Hari. I'm part of the FIanl lab, and my project is to try to simulate the growth of nanowires with a method known as artificial chemistries. And artificial chemistry is any man-made system that tries to model a real chemical system. And this method is perfect for modeling the growth of nanowires. I'm going to run this simulation by Wednesday, and hopefully my results can translate into something that the physics department at PSU can use to grow real nanowires. So, hoping that turns out well. And my stay here has been awesome. I've learned a lot. Like I've learned to program in MATLAB, and really I've learned what research is all about. You know, coming here every day alongside grad students, alongside professionals who do this for a living. It's a great experience. I've learned, you know, a lot of teamwork skills. It's been a great experience. I've learned like skills like perseverance, and I've learned to use failure as a tool to improve. That's the most important part. So hopefully you guys take away something from this little talk I'm giving you, and thanks for listening to me.
Hi, my name is Gabe Petigorski. I've been working here in the FIanl lab for the past few months. So I've been working to help Dr. FIanl out on a collaboration between him and Dr. Jessica Transick of MIT. The project title is Complex Materials Networks Assembled from Simple Nanoscale Building Blocks for Energy Conversion and Information Processing. There, I said it! So, basically the idea of the project is to use this software called LAMPS. It's a molecular dynamics simulator. It stands for Large Scale Atomic / Molecular Massively Parallel Simulator, and I promise that's the last acronym. So, basically, they've been using lamps to try and come up with an optimal design for solar cells. My project has mainly been to take sort of the idea behind the work with lamps and to try and work on something a little simpler in MATLAB. I've been using MATLAB to program an environment like lamps, but a little less realistic. Since the environment I'm making is less realistic, it allows us to test more possibilities a lot faster and to play with a few things that we can't in lamps. My project is definitely not finished yet, but when it is, I hope to be able to incorporate a genetic algorithm to find optimal values and come up with the optimal design for this sort of solar cell. In terms of skills I've gained, things like that, mostly just a lot of practice with MATLAB. I hope that'll be transferable to other programming languages for my future. This has really just been a fabulous time. It's been a lot better than I could have possibly imagined any sort of internship being. And I'm really glad that I signed up. Thanks.
Oh, hi, my name is Shivani Nagy. I'm an intern here this summer at the FIanl lab. My project is called Artificial Life Models for Novel Computing Machines. The goal of my project is to optimize communication between cores on a chip by simulating ant behavior. Confused? Well, ant behavior is characterized by the leaving and following pheromone trails or chemical trails. Soon these ants find the shortest distance to their food source. This ability to communicate indirectly is called stigmergy. Also, in random self-assembled networks like nanowires, the environment is also very unknown, similar to an ant's environment. Currently, I'm working on a simple circuit much simpler compared to the final product of this project. And what I'm doing is my ant has the ability to move to a single specified node and return reinforcing the same path. Soon I hope to move on to multiple ants and enlarge my current circuit to networks on chip. This summer really has been amazing. I've made lots of friends. I've had the opportunity to work with a great mentor. Dr. Tusher has offered so much support on my project, and I will definitely take away so much from this experience. It's been one of the best I've ever had. Thank you.
The goal of my project is to coordinate the activity of nodes so they're in the same state, even though there is no central control. Each node has a state, on or off, that is represented by a 1 or a 0. Each node knows the state of its neighbors. The node's next state is determined by the state of its neighbors and its rule, which is a set of instructions. To coordinate the state of the node, I measure how well each rule is working, and then change the bad rules randomly. This gradual evolution of the rule will eventually lead the nodes to work together on a task. Hi, I'm Eileen, and I'm going to show you our growing slime mold. So I have slime mold number 1, and you can see that there are the darker veins right here, and the veins are connecting the 2 different piles of oatmeal flakes on either end, and they're carrying nutrients from the oatmeal flakes back to the slime mold. You can also see a bunch of littler veins, and these were pretty large at first, but as the bigger veins have grown larger, the smaller veins have receded. So that's kind of interesting there. Then we have another example here, and in this example, I think it's interesting. You can see a great big clump of slime mold growing on the outside. It's that orange thing. You can also see it growing inside the tape on the edges. And here it's less clear that the veins are connecting oatmeal flakes, because we've actually picked out the oatmeal flakes, and hopefully when the oatmeal flakes are picked out, it will congeal into the actual slime instead of looking like more plant-like. So we're waiting for that one. Thank you. The Toysher Lab is awesome at arts and crafts. This is the card I got. I think we need to zoom in of this.
Look at this simulation. You think you're so cool? It sucks.
Hey, what are you trying to say, man?
I'm trying to say that you suck.
What now? Come on.
No, I'm serious. This is crap, man.
Hey, you want to fight me?
Oh, let's go!
You're saying?
Oh, alright. Alright.
Right.
I'm gonna destroy him. I'm gonna destroy him. You can get this on camera, right?
Oh, hey, we were just saying.
Let's go! That's right. Feel the pain, man. Okay, let's go. Oh, hey!
Dr. Tusher again.
Oh, just, working and setting
Yeah,
some scores.
simulations.
Yeah, simulation.
Oh, good, alright. Have fun.
But this is all about honor.